Happy morning, children. Wishing you most and more. Hope everyone are good. So today we are going to just continue with sets, and which is going to be the last topic in this sets also. So the topic of today is practical problems on union and intersection. It's going to be a very interesting topic. So we're going to see some practical problems, kind of word problems, and how to solve that. Okay. So before that, let's see the learning objective of today's session. End of this session, you'll be able to identify what is the Cardinal number. You will find the Cardinal number for the given set, and you will apply the formulas based on the Cardinal numbers, and you will solve problems, practical problems on union and intersection of sets. Okay, so these three things we are going to do today. Well, let's recall quickly as usual. We have seen difference of two sets in the previous class. Union we know, intersection we know, and unfortunately difference of two sets was removed in our curriculum. So anyways, having that knowledge is good. So union and intersection, these two operations only is main, and difference and complementary has been removed from the curriculum. That is why we are directly moving on to practical problems. Actually, after difference we have complement of sets only, that we are omitting it because it is taken away from the curriculum. Okay. So we'll quickly move on to this. Number of elements or the cardinal number of the system. What do you mean by cardinal number of the system? Just if I count the elements of any set and write it, that is called cardinal number or number of elements of this set. Now for example, you can see here, we will always denote the cardinal number as n of a, small n. N of a means number of elements in the set A. So I'll take this set 2, 3, 4, 5, 6. What is n of a to this set? 1, 2, 3, 4, 5. So n of a here is 5. That's a cardinal number. And usually we'll write the cardinal number for the finite set only. For infinite number of sets we cannot write the cardinal number. It is infinity. So we'll prefer cardinal number only for the finite set. So remember this, based on this cardinal number only we are going to deal all the problems and formulas. Okay. So this is very important slide. Formula to solve practical problems on union and intersection of two sets. What are the formulas I have to solve problems based on union and intersection? Now I'll take three sets ABC, and all the three sets are finite set. Finite set means the number of element is countable. We can count a finite number of elements it has. The first formula based on cardinal number is n of A union B is equal to n of A plus n of B minus n of A intersection B. This is a formula. Actually, when we find out A union B, how many elements will be there in A union B? That is what is n of A union B. A and B elements we will just unite, right? So all elements of A and all elements of B will be there. So all elements of A is n of A, all elements of B is n of B. That will be there. But usually when we find the union, what will happen? When there is a overlapping, when there is a common element, we will just leave that. We won't repeat it. So the common elements will just leave it. That is why that symbol is given as minus. So how many elements will be there in union of two sets? Is a formula to find out this. It is n of A plus n of B minus n of A intersection B. With the same logic, we have few more formulas. So based on this formula, we are going to solve few problems now. Quickly we'll solve the problems. First question, if x and y are two sets such that n of x is equal to 17, n of y is equal to 23, and n of x union y is 38, then find n of x intersection y. Very simple. We know the formula for n of A union B. Just apply all the values and find the unknown value. Just write this givens first. N of x is 17, n of y is 23, and n of x union y is 38. And we know the formula for n of A union B. Just replace A and B as x. Let's see the next question. In a group of 400 people, 250 can speak Hindi, 200 can speak English. How many people can speak both Hindi and English? This is what is the question. So there are two categories here, people who speak Hindi and people who speak English. So let us have two letters for this category. So I'm going to take H set H as set of people who speak Hindi. Similarly, set E as set of people who speak English. Okay. Now you write what is, this is number of people. So N of H and N of E is given to you. Just write N of H is 250, N of E is 200. That is number of people who speak Hindi is 250. Number of people who speak English is 200. And what is this 400? It's a group of people. Totally there are. Next question. In a group of 70 people, 37 like coffee, 52 like tea, and each person likes at least one of the two drinks. How many people like both coffee and tea? See here again two cases, two categories. People like coffee and people like tea, and there are totally 70 people. Each person likes at least two of the two drinks. Okay, out of that 70, each person likes at least one of the two drinks. So everybody are included. There is nobody like they don't like tea or coffee at all. So everybody likes either tea or coffee, at least one of it, or both also some people will like. So that is the information given. If this information is given, then N of A union B is 70. Now how many people like both coffee and tea? Same kind of question what we have seen in the previous. Both coffee and tea. So I need to find out intersection. Let us take the set notation first and then we'll deal. So set C is people like coffee, set T people like tea. Okay. So it is given that there are totally 70 people, so I will take it as C union T. People like coffee, people like tea. That's it. Just put it in. Let's move on to the next sum. In a group of 65 people, 40 like cricket, 10 like both cricket and tennis. How many like tennis only and not cricket? How many like tennis? There are two questions in this. Okay, just read the question clearly. Totally there are 65 people. Okay, so 40 like cricket, 10 like both cricket and tennis. How many likes only tennis? And they don't like cricket, they like only tennis. And how many like tennis? Generally, how many like tennis? Those people can like cricket also. Okay, how many like tennis means they can like cricket also. But how many like tennis but not cricket means I want the exclusive members who likes only tennis. It is like A minus B. Okay, this question is I need to find out A minus B. I need to find out A minus B. This is N of A. This is N of A minus B. I want only the first element exclusively. So we'll see the question by the given information. These three numbers are given to us. So I'll take that as C and T as the sets. C people likes cricket, T people likes tennis. So totally there are 65 people. So I'll take that as C union T, which is equal to 65. People like cricket. So enough C is 40. 10 like both cricket and tennis. Both. They like both. It is common. So I'll take that information as N of C intersection. This is what is the given information to us. Okay. So from this we need to identify what is N, how many like tennis only not cricket. So in terms of C and T, you tell me how many likes tennis not cricket. What actually we need to find out? It is N of T minus C. Actually this is what we need to find. For that we have a formula. N of A minus B formula we have. N of A minus N of A intersection B. That is a formula. So here N of T minus C is there means the formula will be N of T minus N of T intersection C. This will be the formula. So to apply that formula, first of all I need N of T. Okay, N of T is not given in the question. So let's try to find out N of T first, and then we can find out what is N of T minus. So our next question, in a committee 50 people speak French, 20 speak Spanish and 10 speak both Spanish and French. Okay, how many speak at least one of these two languages? At least one of these two languages. Now this is for you to try. You need to find out X into. So practice well, do all the sums in your classwork, including the homework sum. All the sums will be there in your classwork. Okay. So thank you children. Have a great day.